All right, we're back. We're on page 7 of note 17 of Calc C. We're doing polar stuff. We've talked about dr d theta, dx d theta, dy d theta, dy dx. Then we talked about tangents at the origin, which are just set r equal to 0. And then we talked about the calculus of why those are the tangent lines. But let's see if we can do this problem. So we have a cardioid, 1 plus sine of theta. So I know that 1 plus sine of theta is going to be predominantly on the positive y-axis. And it's going to look like, so it's cardioid, so it's going to look like kind of that. You don't really need the graph, and in fact, sometimes having just the rectangular graph is enough to work things out, but it's also good to know what these things look like, so hopefully I got that right. All right, let's find the slope of the tangent line. No, show that the slope of the tangent line to the graph is -1 when theta equals pi over 3. All right, so what we're going to do is first we're going to write our polar curve in parametric, right? So it's x is going to be r, which is 1 plus sine of theta, and then cosine theta, and then y is going to be r, which is 1 plus sine theta, and then sine theta. Okay, so to find dy dx, we need dy d theta and dx d theta, and to get those, we're going to use a product rule, and so it's going to be delightful. Here we go. So I'm going to start with dy d theta. It's going to be the first. I mean, it's like the process is almost the same for both of them. Derivative the second. I'm going to not put parentheses around the arguments of the trig functions, which like kills me, but it's just so much less writing. Plus second. Derivative of the first is just cosine of theta. Okay, and then I'm going to find dx d theta. I think what I'll do is evaluate both of these at pi over 3 and then just divide those and see that I get -1. So first, so this is where you can see the structure of it is like almost identical. Derivative of the second is negative sine of theta, and then plus second, which is cosine, and then derivative of the first is cosine. So there's like work that you could do to simplify this if you wanted to. And then do I want to do that? I might, because in the next part I have to find where the tangent is horizontal, which means where dy d theta is 0 and dx d theta is not 0. And then I want to find where it's vertical, which means dx d theta is 0 and dy d theta is not 0. So I may want to simplify these, but I definitely don't want to simplify these, if you're not picking up on that. Let me see. So I'm going to do, what am I going to do? I'm going to use the fact that sine of 2 theta is 2 sine theta cosine theta. So I'm going to use this fact. And then if you look at this, you would get cosine theta and then sine cosine plus sine cosine is 2 sine cosine. So this can be reduced down to cosine of theta plus sine of 2 theta. And then this one, I'm going to end up with cosine squared minus sine when I distribute. I mean, this is obviously cosine squared. And then negative sine squared. So I have cosine squared minus sine squared. I'm going to use the fact that cosine of 2 theta is cosine squared minus sine squared. So it pays off to know 14 formulas. It's like, is it mandatory? I don't really know. But I'm going to write this as cosine of 2 theta minus sine of theta. I'm also going to check my answers. So, well, actually, if I get -1, I know that I'm right. So let's do dy d theta such that theta equals pi over 3. Okay, so cosine of pi over 3 is -1/2. No, it's pop. What am I doing? 1/2. And then the sine of 2 pi over 3 is the sine of 2 pi over 3 is radical 3 over 2. It's just not as simple as I thought it would be. Dx d theta. Okay, the cosine of 2 pi over 3 is -1/2 minus the sine of pi over 3 is radical 3 over 2. Okay, so this is the negative of 1/2 plus radical 3 over 2. So therefore, dy dx is, you can see it's -1 because this is 1 half plus radical 3 over 2. This is 1 half plus radical 3 over 2. We're dividing them, so you just get -1. And that's what we wanted to do. So I don't know. I'm going to put like the little box and say that we did our job, right? dy d theta over dx d theta is -1. That's dy dx. All right. Find the values of theta for which the tangent to the curve is horizontal. Okay, so that means that horizontal means that dy d theta has to equal 0, which means I may actually not want to use my simplified version of this. I think I might want to use, so I mean, I got cosine of 2 theta minus sine theta, but I think it, oh no I didn't. I got cosine of theta plus sine of 2 theta. I think it's probably actually better, right? I think it's probably better to use cosine of theta plus 2 sine cosine, because sine of 2 theta is this. I'm going to do that because I can factor it. So I'm going to say cosine plus 2 sine cosine equals 0. And then let's just confirm that's right. I think that's right. Take out cosine, get 1 plus 2 sine theta equals 0. So cosine of theta equals 0. And that happens at theta equals pi over 2, ew, what? Pi over 2 and 3 pi over 2. And then sine of theta equals -1/2, which happens at 7 pi over 6 and 11 pi over 6. Okay, so just like visually, does that make sense on our graph? So 3 pi over 2, I think, is not going to work out. But pi over 2 looks like it will work out. So here's my graph, right? So what I'm saying is, I think that at pi over 2, definitely. I think that 7 pi over 6, if I had done a good job, seems right. And then 11 pi over 6, if I had done a good job, seems like it'd be right. 3 pi over 2 seems like it's not going to work. Let's check dx dt at 3 pi over 2, dx d theta. So at theta equals 3 pi over 2, dx d theta equals, so I get the cosine of 3 pi. I'm just plugging in here. Cosine of 3 pi, and then minus the sine of 3 pi over 2. Okay, so then dx d theta is going to be, the cosine of 3 pi is -1. The sine of 3 pi over 2 is -1, but it's minus that, so minus -1 equals 0. So that's it. We ran into that situation where we need dy d theta to equal 0, dx d theta to not equal 0. So actually, you can see on the graph that the tangent line goes vertical there, or seems to. And so that's what made me skeptical. The other ones, I don't think I even need to check. So I'm going to say the value, so theta, when tangent horizontal, going to be theta equals pi over 2, 7 pi over 6, and 11 pi over 6. Not at 3 pi over 2, because dx d theta is also 0. So like technically what we really need to do is we need to look at the limit as theta approaches 3 pi over 2 of dy d theta over dx d theta, which I do not want to do by hand. When I switch to the calculator, I will take a look at that. But for now, I'm going to leave these with like the 3 pi over 2 is the big caveat. So when is the tangent line vertical? Is there like a super good way to do this? Okay, well, I don't know about a super good way, but I'm going to take this. So, I mean, I need dx d theta to equal 0 and dy d theta to not equal 0. So dx d theta equals 0, dy d theta not 0. Not necessarily 0. It could be 0, but we have to like watch out for that. So like here, I also should have said in parentheses, watch for dx d theta equals 0. Right, we just have to watch for it. We have to be careful because it can be an extraneous solution, which I think we saw with 3 pi over 2. So I'm going to take dx d theta, which is cosine of 2 theta minus sine of theta, and I'm going to do a, it's easier to think of it. I'm gonna use 14 formulas. Cosine of 2 theta equals, man, I just keep being in the way. Cosine of 2 theta is 1 minus 2 sine squared. So cosine of 2 theta minus sine of theta. Cosine of 2 theta minus sine of theta equals 0. Cosine of 2 theta is 1 minus 2 sine squared of theta minus sine theta. Multiply through by a negative, I guess. 2 sine squared plus sine minus 1 equals 0. Factor it. 2 sine theta. Sine theta. I just assume this will factor because like you almost always get famous angles. So I'm going to put plus 1 here and minus 1 here. So I need sine of theta to be positive 1/2. That's interesting. And we need cosine. Why would I write cosine? We need sine of theta to equal -1, which is 3 pi over 2. Okay, so this is going to be at pi over 6 and 5 pi over 6, which if you look at it, those are almost definitely right. I mean, it depends on the angles that put you there, but like that feels like it could definitely be right. And then also at 3 pi over 2. Now this is the interesting one because we know that y d theta is also 0 there. So what I'm going to do is I'm going to look at the limit as theta approaches 3 pi over 2 of dy d theta over dx d theta. I'm going to use a calculator. I think you do L'Hopital's on it if you want. I think this limit's not, I think, going to not exist. I'm going to switch to the calculator because we need the calculator help. So let's see, what should we define? I'm going to define r of t. So I always use t. R of t is going to be 1 plus sine of t. All right, so x of t is going to be r of t cosine of t, and y of t is going to be r of t sine of t. Okay, so then dy dx of t is going to be the derivative. So you should use the templates. It's just faster for me to type it, but I'll use it this time. With respect to t of y of t, and then derivative x of t with respect to t. Okay, so that's dy dx. So what am I trying to do here? Let's solve. Derivative of y of t with respect to t equals 0 for t. Let's limit it from 0 to 2 pi. So we get all of those values. Those are the values that I think we found. Let's solve. Let's just borrow this and change it to x. So like right now I'm thinking that those values on screen are where the tangent line is horizontal because that's where dy dt equals 0. But, oh, interesting. Why can't you solve that? Why? Derivative x of t, comma t. Why can't it solve that? Let's trig collect. Let's trig expand. Let's do such that cosine, no, I need to replace the cosine squared. I think that if I change it to 2, cosine squared is 1 minus sine squared, and then minus sine, and minus 1, right? So I'm just doing the, like, sometimes the calculator gets stuck like this. And then the more trig you know, the better off you'll be. But this, why? These are like bad values? Am I doing it wrong? Oh, well, that's obviously wrong. how do I get this? I need the sine itself to be squared, not that. There. Why won't you solve that exactly? What is your problem? Will it solve, if I expand it by hand, will it solve it? 2 sine squared, sine of t. This, I was not expecting this, so that's fun. What did I get by hand? Plus sine of t minus 1 equals 0 for t. I feel like I'm stuck in an annoying analysis problem now. There we go. Let me tell you, I ate a vanilla cream donut before that had like powdered sugar on it. And I like breathed in the powdered sugar and it's just been killing me in the back of my throat. I'm like trying to fight it off. It's not working very well. All right, technological issues, many of which are related to me typing things wrong. So let's see. Okay, here's what we had wanted, right? dy dt equals 0, dx dt equals 0. So you can see 3 pi over 2 shows up in both of them. So now let's do the limit of dy dx of t 3 pi over 2. It shouldn't, I think it doesn't exist. It's undefined. So it's undefined because you're going to infinity. So it's actually a vertical tangent line there. So it is a vertical tangent line. So in my notes, I'm writing that limit does not exist. Therefore, vertical tangent there as well. So now it doesn't exist in like, it's infinity from one direction. It's a cusp. It's infinity from one direction, negative infinity from the other. Maybe can I fit that in? Let's do from the left, and you get infinity. Let's do from the right, and you should get negative infinity. So it's a cusp. It's like boom. I still think it's a vertical tangent line. I think that what would happen is they would avoid this issue on like the AP exam, perhaps. Okay, so our vertical, yeah, I think we're done with the problem. Let me go back to the notes. My throat, man. It's powdered sugar killing me. Powdered sugar. If that's not a message about like don't eat powdered sugar to me, I don't know what is. These are our values where we have vertical tangent lines. We got our horizontal tangent lines. We showed that the slope was -1. That was really nice. It helped that I could draw the graph. I think that you would find that useful as well. But it's not really mandatory. But that 3 pi over 2 insight kind of came from the fact that, yes, I could draw the graph and I could see like that's definitely not a horizontal tangent line. So I'm going to stop this here. We'll be back in the next video to do some more. So I will see you there.